Okay, in this lesson, what we're going to cover is 3-4, solving inequalities using addition or subtraction. An equality is very much like an equation or expression that we've been solving, with the exception of it has a different symbol in it. An inequality is a statement formed by placing an inequality symbol between two expressions. An example of an equality looks like this. As you can see, it looks just like an equation, except this would be read y plus 5 is less than or equal to a -6. The different inequality symbols are listed here. And what they mean, when you look at this one, that can be read as less than. This means less than or equal to. This one means greater than. And this one means greater than or equal to. Here we're going to fill in this chart. And we're going to read what it says and write it in words. This inequality is read x is less than 3. And what that means is that all numbers less than 3. Y is greater than 2. That is referring to all numbers greater than 2. So any number bigger than 2. Z is less than or equal to 4. So all numbers that are less than or equal to 4. N is greater than or equal to 2. This means that n can be all numbers greater than or equal to 2. So if it's 2 or bigger, that's what the value of n can be. Before we move on to graphing, I want to show you some symbols. If this symbol or this symbol is used, that means that it is graphed with an open circle. And what I mean by that is this. If we have a number line and we have our line there, when we are graphing a less than or greater than symbol, you're going to mark it with an open circle. If it is the less than or equal to or greater than or equal to, those are graphed with a closed circle. So again, if I have my number line and I have the mark, it's going to be filled in, a closed circle. So now let's go back to our charts here and graph what we just covered. Oops, I went too far. If we wanted to graph x is less than 3, I'm going to find my value 3 on the number line, and I'm going to change my color just so you can see it a little bit better. Here's my 3. I want anything less than 3, but because it's the less than symbol, I'm going to use an open circle and any number less than 3. So that means that x can be any of these numbers on the number line. If I'm graphing y is greater than 2, that's telling me that y is going to be any number bigger than 2. Notice my open circle. Z is less than or equal to 4. Well, if z is less than or equal to 4, that means that z can be 4, or it can also be any number less than that. N is greater than or equal to 2. N can be equal to 2, or it can be any number bigger than that. I'll give you a couple of seconds to fill in that chart. Okay, moving on to the next page. Here we will be writing and graphing inequalities. In this problem, it tells us that the freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, water is a solid. It becomes ice. The directions are to write an inequality that gives the temperatures at which water is a solid, and then graph that inequality. So for our solution, we're going to let T represent the temperature of the water, and it's telling us that water is a solid at temperatures less than or equal to 0 degrees. So when we write our solution, we're going to use our variable T, and it tells us that our temperatures are less than or equal to 0 degrees. So our symbol to show less than or equal to 0. And from there, we're going to graph it. So we draw a number line. 2 arrows on the end show us that the number line keeps going. And we're going to just count by tens. And if I'm graphing this, I again want to show that T can be not only less than 0, but it can also be equal to 0. Because I have this symbol, I'm going to use a closed circle at the 0. That's showing that T can be equal to 0, but T can also be less than that. So any number less than 0 would include all of the numbers to the left of 10 on the number line. And that's how we can graph. If we are solving inequalities, we're going to use equivalent inequalities. And those are inequalities that have the same solution. And the properties of inequalities are very similar to the steps that we would take to solve our equations that we just covered. In words, it says that adding or subtracting the same number on each side of an inequality produces an equivalent inequality. So in our first example, if I have A is less than B, if I add C to this side and I add c to that side, they're going to be equivalent. The same thing happens if I'm subtracting. And when you're solving, you're going to follow the same basic steps as when we were solving equations. Remember, the first thing we did is we use inverse operation. And then we do the same to both sides. Let's practice a couple of these solving inequalities. In the first one, we're going to use subtraction to solve the inequality. The first thing you want to do when you get that inequality is you want to rewrite it. So I'm going to take my m plus 5, and that is greater than or equal to 10. I'm going to create my 2 halves. I want to isolate my variable. I want to get the m by itself, which means I'm going to do the inverse. I'm going to subtract 5. I'm going to subtract 5. And what happens there is this cancels out. I now have left over here m. Instead of an equal sign, I have my greater than or equal to, and then 10 minus 5 is 5. So my solution for this inequality is m can be greater than or equal to 5. When I graph that, I have my number line. Here's my, oops, I didn't want to do that. Hold on. Here is my 5. I'm just going to count by ones. And if I wanted to show this, m is greater than or equal to 5. I'm going to find my 5, greater than or equal to. Since m can be equal to 5, I'm going to use a closed circle. If m can be greater than that, then m can be any number greater than 5 on the number line. Now, when you check an inequality, in this particular inequality, if m can be equal to or greater than any number greater than 5, when you're checking, you can choose any number greater than 5. So I'm going to rewrite my inequality. And if I can pick any number to represent m that is greater than 5, I'm just going to go with 8. And I'm going to say, okay, if I choose m as 8, I'm going to add that to 5. Is that going to give me a value that is greater than or equal to 10? So I'm going to solve. 8 plus 5 is 13. 13 is greater than or equal to 10. So that checks out, that works. In this example, we're solving an inequality using addition. Follow the same steps. We're going to rewrite our inequality. Negative 10 is greater than x minus 12. Now, some of you may want to rewrite it and switch the sides. You can do that, but there's one little trick when you're dealing with inequalities. Since it's not an equal sign, you have to make sure you do one more thing. If I wanted to take this and write that first, I can do that. And then I want to take my negative 10 and put it over here. But I have to pay attention to my symbol and what direction it's facing. The greater than sign is facing the 10. So when I rewrite it, I need to make sure that that symbol side is facing the correct way. Since I switched sides, I also need to reverse the direction that my symbol is facing. Don't forget to reverse your symbol if you're reversing the sides of the inequality. If we're going to work off of this one, we're going to follow the same steps. Use our inverse operation. I want to isolate the x, so we're going to get rid of the 12. Do the same thing to both sides. I get rid of that. That leaves me with x. Bring down my symbol. X is less than negative 10 plus 12. X is less than, if I'm adding two different signs, I find the difference. So the difference between 10 and 12 is 2, and I take the sign of my larger number, which makes it a positive. When I graph that, I can say that my solution is x is less than 2. So I want to graph that. I'm just going to put 2 in the middle. If x is less than 2, I'm using an open circle. X cannot be 2. X is any number less than 2, so it's any number to the left of the 2 on the number line. And again, when we are checking, you're going to want to use any number less than 2. So when I write my equation, x minus 12 is less than negative 10. And since I can use any number less than 2, if x is less than 2, well then x could be 1. So I'm going to use 1. And now I'm going to follow my integer rules. 1 minus 12 is negative 11. And I want to see, does this half, is it less than negative 10? Well, negative 11 is less than negative 10. It's a smaller number, so that checks out. Once you're done copying this problem down, what I would like for you to do on the back of this page, there are 4 problems down here that I would like you to try. You're going to solve them, you're going to graph them, and you're going to check your solution just like I did on the first 2 problems. Good luck, and rewatch the video if you need to or if you missed any information. See ya in school.